All right, let's look at part B. We have 5x minus 2, x minus 2 quantity squared. The bottom is quantity squared, so going back to our table here, first of all, we don't have any improperness here because of the fact that in part B we have linear at the top and quadratic in the bottom. So we eliminate the first item here, and we're going to factor the denominator. And as you see that it's already factored, right? In part B, it's already factored because I have x minus 2 quantity squared term here. It's already factored, so I don't need to worry about that. So that makes me go to item number 3. If you have linear factors, which is what I have, I'm going to write the decomposition based on the power of the linear factor. In this case, it's m. Okay, so I have a quantity power of 2. So I'm going to keep one term without the power in the bottom, and I'm going to put one term with the power 2 in the bottom. Okay, this is how the factorization or partial fraction in short works for this one. So in other words, I'm going to look at 5x minus 2, x minus 2 squared is a over x minus 2 without the power, plus another constant, let's say b, x minus 2 squared. You can go with a1, a2 if you want to, but our task is to determine those constants, so it doesn't matter what you call them, okay? So now I need to find a common denominator on the right-hand side. That is me multiplying this fraction by x minus 2 at the top and the bottom. That's enough, right? So here we go. I have a times x minus 2 plus b. So now I have a common denominator that's equal to the fraction that we start with. Okay. Well, this implies that 5x minus 2 has to be equal to a times x minus 2 plus b. Okay. All right, let's have sample values for x. So why don't we go with x equals 2 to start with. So 5 times 2 equals 10 minus 2 is 8. So b is 8 because the a term is gone once you plug in 2. And I'm going to just choose any number to as a sample x. Let's just pick x equals 3, okay? So x equals 3, the left-hand side is 13 because it's 15 minus 2, 8 plus b. And b was 8 from the previous step, so that makes a to be equal to 5. Okay? So 5x minus 2 divided by x minus 2 quantity squared is factored out as a over 5 over x minus 2 and 8 over x minus 2 squared. Okay, 8 plus x minus 2 squared. Okay, great. So if I want to integrate this, here we go, I'm integrating this. I am integrating this, and I am integrating this. Okay? So let's see what we can do. Well, I think we're going to use u substitution for each case. We can use the same u, in fact. So let's take u to be x minus 2 so that du is exactly equal to dx. Okay? So now this integral becomes 5 times du over u. Sorry, 1 over, let's see, 1 over u du, right? I'm sorry. In other words, du over u. Yeah. Didn't I say du over u? All right. Plus 8 du over u squared. Okay. One is a special type of integral. It's 5 ln u. And for the other one, we're going to use power rule for integration because this is equal to u to the minus 2 du. Okay. And I can use power rule for integration. 8 u to the minus 1 divided by minus 1 plus c. And let's go back to the original variable, so back substitution, ln x minus 2 plus minus, in fact, minus 8 over, so u to the minus 1 is 1 over u, so it's 8 over x minus 2 plus c. Okay. All right, this was a shorter video. This takes care of part B. I'll see you in the other video for part C. Bye.